Hey everyone, this is Bhargav Suthar, and today we will discuss some more types of graphs. So basically this is the last and third part of the types of graphs. Okay, so in this today's session we will discuss some more rest of the types of the graphs. Okay, so first let us understand what is a bipartite graph. So the definition, capital G, it is a graph whose set of vertices is capital V. Now if V can be partitioned, so as the name bipartite, so if V can be partitioned into two subsets, let us name it this V1 and V2, okay, such that every edge of G just joins V1 with V2, okay, and also this V1 union V2, it is V. So what is V? It is a set of vertices, and this V1 intersection V2, it has to be phi, okay. Remarks, so the first one, vertices of V1 are not joined, okay, and in same manner vertices of V2 are not joined. Now third, now bipartite graph cannot have self loop, okay. Now let us discuss example. What does that mean? Now just consider this four vertices having this graph. Now see A, B, C and D. Just consider this partite set, that is AB, as V1, okay, and second partite set, that is CD. So that is let us name it as V2. See V1, the vertices of V1 and V2 are not joined. As you can see that here they are not connected, and in same manner vertices of V2, they are also not joined. Now then this V1, it is joined to V2, and the elements of V1 are joined to V2, and elements of V2 are joined to V1, as you can see that, okay. So it is a bipartite graph. Fine. Now let us consider this type of example. Now just by looking at this graph, it would not be a bipartite graph, but actually it is a bipartite graph. So what we'll do, see, we need to have this two sets, this V1 and V2. So first in V1 as this A, C, E and G, okay, and just take V2 as the other alternate vertices, that is B, D, F and H, okay. So what we'll get, so obviously this V1 union V2 will be V, okay, and their intersection is also phi. Now you can see that this vertices of this V1, A, C, E, G, this A, C, then E and G, they are not connected, okay, in between, and in same manner V2, they are also not connected. But as you can see that this vertices of A and V1 and V2, they are connected. So as you can see that this A and B are connected, this A and D are connected, A and H are connected, A and F are not connected, but that's okay, fine. Each and every vertices should not be connected to each and every vertices of the other side, fine. So this is a bipartite graph. Now let us discuss what is a complete bipartite graph. So first, a bipartite graph, it is known as a complete bipartite graph. So first it has to be a bipartite, fine. Now if each vertex of V1, it is joined with every vertex of V2, okay, in previous example it was not the case. So one vertex was left. So here if each and every vertex of V1, it is joined to each and every vertex of V2 or the other bipartite set, and it is denoted by this KMN, where this M, it is number of vertices of V1 and N, it is number of vertices of V2, fine. And the total number, we have the formula, the total number of edges in a complete bipartite graph, that is KMN, it is M into M, okay. So for example, what will be K22? So it is a complete bipartite graph and having 2, so one bipartite set has two vertices and another bipartite set has two vertices. So as you can see that this A and B are not connected, C and D are not connected, and this A, it is connected to each and every vertices of the other bipartite set, and in same manner B is also connected to each and every vertices of another bipartite set, and in same manner for C and D it holds, okay. Now what will be K23? So that means in one bipartite set we have two vertices, and in another bipartite set we have three vertices. So this will be the graph. As you can see that we have two vertices and here we have three vertices. Now this V1, vertices of V1 are connected to each and every points vertices of V2, and in same manner for V2, okay. And just by this formula M into N, so it will contain total 6 edges. So you can count, they are 6, fine. So this is a complete bipartite graph. Now let us discuss what is a star graph. So a complete graph of the form this K1M is known as a star graph. So it is a complete bipartite graph, but here the number of vertices of one partite set, that is fixed, okay, and that is 1. And for the second partite set, it can be anything, okay. So for example, this K16, so what will be the graph of K16? So it will be like this. As you can see that one partite set is what? This A, okay, and the other partite set, it is this B, C, D, E, F, G. Fine. So as you can see that just by looking at this, it is of the form star, so that is why it is known as a star graph. Fine. So this is a star graph. Now let us discuss examples. So the question is, draw a complete bipartite graph which is not regular. Now see, what is complete bipartite graph? We know that. Now what is a regular graph? We have already discussed in previous sessions. So what is a regular graph? A graph in which each and every vertex has the same degree. Okay, so we'll draw this type of graph. So it will be K16. So as you can see that it is a complete bipartite graph. Okay, and here you can see that the degree of A, that is 6, and degree of rest of the vertices, that is 1. So that is not possible. It is not regular, but still it is a complete bipartite graph. Fine. So let us discuss another example. So the question is, draw a graph which is regular but not bipartite. Okay, so regular, so that means each and every vertex has degree same but not bipartite. Fine. So what will be the graph? So this will be the graph. How? See, you can see that this degree of each and every vertex, that is 3. Fine, but it is not bipartite. Why? So that means we cannot distribute or divide this partite set into 2 such that they are not connected with each other. Fine. So as you can see that just take this point and this point, but they are connected. Just take this point and this point, but they are connected. Just take this point and this point, but they are connected. So it cannot be a bipartite graph. Now let us discuss what is a subgraph. Okay, so let G equals to VE be a graph. So a graph H, the another graph, that is V dash E dash, is said to be a subgraph of G if this E dash, it is a subset of P, E, and V dash, it is a subset of V. Fine, such that this edges in E dash are incident only with the vertices in V. So just take example. Fine, see, consider this K22. So this is the K22, and see here we have this such that the edges are incident only with the vertices in V. So this can be the subgraph. Why? Because you can see that this graph, it is a subset of all this, the K22, so it will be a subgraph. Fine, it is very easy. Now let us discuss what is a spanning subgraph. So first of all, it has to be a subgraph. So a subgraph of G is said to be a spanning subgraph if it contains all the vertices of G. Now in previous example, the one vertex was left, okay, but still it was a subgraph. But in spanning subgraph, all the vertices has to be there. Okay, so let us discuss example. So the same example, this K22. So the spanning subgraph, it will be like this A, C, B, and D. So as you can see that here all the vertices are covered and it is a subgraph. So this is a spanning subgraph. Now what is a complement of a subgraph? So the complement of a subgraph, this H1, that is V dash E dash, with respect to the graph G, it is another subgraph, this H2. Let us name it as V double dash E double dash, such that this E double dash equals to E minus E dash, and it contains only those vertices which has endpoints of E double dash. Let us discuss example. See, by examples it will be very clear. So now this is a graph. Let us consider this as a subgraph. Okay, now what is the complement of this subgraph? So that means it will be like this. See here, whatever the edges are there, so you can see that these are the edges. Now what are the left edges? So that means you can see that here we have total 3 edges, and here we have total 6 edges. Fine. So except 6, all the 3 edges will be there. So except this 3 edges, all the edges will be there in the complement of subgraph. And if we combine both the graphs, so we'll get the main graph. Okay. Now what is a null subgraph? So a subgraph constructed from a given graph by deleting all the edges of G, it is called a subgraph defined as a null subgraph, and it is very easy. It is denoted by the symbol NN. Okay, so this will be the null subgraph having 4 vertices, so that means it is N4. Okay, now let us discuss what is a complement of a graph. In previous it was complement of a subgraph, Now here it is complement of a graph. So don't get confused between all this. Fine. Now see, so let G be a simple graph. So first of all, it has to be a simple graph. So that means no self loop and no parallel edges are there. Fine. Now the complement of G, it is denoted by this G bar, and it is the graph whose vertex set it is same as the vertex set of G. Fine. And in which two vertices are adjacent if and only if they are not adjacent in G. Okay, so let us discuss another example. So just consider this graph. Okay, so what will be the complement of a graph? So as you can see that the vertex set are same, but here these two vertex are not connected. Okay, so that means this edge will be there and rest of the edges are not there. Fine, so it is a complement of graph. So it is a graph in which you can see that in this graph two vertices are adjacent, so in this complement it won't be adjacent. So you can see that it's very obvious. Now note, now see, a graph is known as self-complementary graph if it is isomorphic to its complement. Now we have done what is isomorphic. Okay, so let us consider this. See, this is a graph. Fine. So what will be its complement? So you can see that we have covered all the vertices. Now these two are not adjacent, so that means it will be adjacent here. These two are not adjacent, so that means this will be adjacent here, and these two are not adjacent, so that means this will be adjacent here. But just by looking at this, it is the same graph, so that means it is a self-complementary graph. So after getting the complement of the graph, we are getting the same graph, so that means it is a self-complementary graph. Okay, now let us discuss what is a path or a walk. So a walk of a graph G, it is an alternating sequence of vertices and edges. This V0, E1, V1, E2 and so on, beginning and ending with the vertices, in which each edge it is incident with the two vertices immediately preceding and following it. See, it is very easy. And this path or walk joins V0 and Vn. Now if this both are same, so that means this beginning of the that means this starting vertex and the end vertex, they are same, then we can say that it is a closed path or a circuit. Now if V0 and Vn, they are different, so that means it is called an open path. Now for example, see, consider this type of graph. Fine. So what will be the path? So just take this B even. So B even A, then E4, then C, then E5 and D. So it is a path, and it can be any path. Okay. So it is just start from a vertex, end with a vertex, and this edge are alternating. So that means just, we will write in this pattern. This B even A, then E4 C. So it is a path, simple path. Okay, it is a path. Now this, if we start from here, so A, E4, C, E5, D, E2, and then again just go to A. So it is a circuit. Why? Because it is a closed path and the starting point and the ending point, it is the same. So it is a circuit. Okay. Now, what is a simple path? So a path in a graph, it is called simple if the edges do not repeat in the path. Fine. So let us discuss example. So here the same graph. Fine. So just consider this B, even A, E4, C, E5 and D. It is a path. So as you can see that we have not repeated any edges. So it is a simple path. Fine. Now what is an elementary path? So a path is said to be an elementary path if vertices do not repeat. In simple path it was for edges, and here an elementary path if vertices do not repeat. For example, the same graph. Okay, so let us discuss another path. It is the same path, and obviously we have not repeated any vertices, so the same path will work. Okay, now what is a simple circuit? So a circuit in a graph G is said to be a simple circuit if it does not include the same edge twice. Okay, for example, the same example. So just consider this A, E4, C, E5, D, E2 and A. It is a simple circuit and which does not include the same edge twice. So this is a simple circuit. Now what is an elementary circuit? The same manner if it does not include the same vertex. Okay, so it will be an elementary circuit. So the same graph and the same circuit will work because we are not covering the same vertex twice. So it will be an elementary circuit. So these are the types of the graphs. Okay, thank you.